Okay, so let's take a look at another electromagnetics question. We've got two parallel current-carrying wires exert a force on each other. How does the force change if 1, distance is doubled, 2, both currents are halved, 3, one current is halved, or 4, one current is zero? Okay, so we need to use our force formula. So we have the force is mu naught times the length of the wire times current 1 times current 2 divided by 2 times pi times the distance. So if the distance is doubled, this means r goes to 2r. If we plug this in, this is F1, we find that force 2, the new force, is mu naught times length times current 1 times current 2 over 2 times pi times 2r. This is 4 pi r. This is 1/2 times force 1. You can factor the 2 out of the denominator. So what happens if the distance between them is doubled? The force is halved. So in the case of part 1, force is halved. So now let's think about what happens if both of the currents are halved. So same equation, force 1 is mu naught times length times current 1 times current 2 divided by 2 times the pi times the radius. Well, if current 1 is halved, this means current 1 goes to, it's going to be 1/2 of current 1, which is going to be current 1 divided by 2. And current 2 is halved, this means current 2 goes to current 2 divided by 2. If we plug these in, we find our new force, force 2, is mu naught times length times current 1 on 2 times current 2 on 2, all divided by 2 times pi times the distance, r. Now we have a 1/4 factor in the numerator. So this is 1/4 times force 1, which is factoring the halves out of the I1 and I2 terms. So what happens? The force is reduced to 1/4 of the original force. So it goes down. If it was 100, it goes down to 25. It goes down to 25% of the original force, reduced to 1/4. So this is the answer to part 2. Now for part 3, we want to know what happens if one of the currents is halved. Well, it's going to be very similar to the previous part. In this case, we only need to set one current to that current divided by 2. So we're going to find that the new force, force 2, will be mu naught times length times current 1 over 2 times current 2 divided by 2 times pi times the distance between them. Well, this is force 1 multiplied by 1/2. We've got this half factor in here. And so this means that the force is halved. It's reduced by 50%. If it was 100, it's down to 50, or whatever it was. It's half of that now. And then for part 4, we're told if one current is reduced to 0, well, if I1 goes to 0, we find force 2 is this whole expression without the I on 2. With I equal to 0, well, it's just 0, right? So if one of the currents is equal to 0, there's no force. You need 2 currents for there to be forces. If one is reduced to 0, the forces just go away. And so this is how we do this question.